Of the students, and we have a lot of different faces here today, is go around and just give a brief, your name and where you're at, where you're from, so that Scott and some of the students can see some of the people that are here in attendance today. So if you remember to use the microphone, we are broadcasting live over the web, so just touch the button and hold it down when you make your introduction. So welcome you to Portland State. I'm Chris Monsieur, faculty member in Civil and Environmental Engineering, and with Jennifer Dill and Rob Bertini, we're the ones who sort of organize and co-host this seminar. So with that, we'll start up here with introductions.
I'm John Sway, and I'm a first-year urban and regional planning student.
Dave Meyer, professor in computer science.
Peter Mason, I'm from Portland Transportation.
Rob Birchfield, city traffic engineer for the City of Portland, Portland Transportation.
Don Crownover from ODOT's traffic counting program.
Teddy Baker from ODOT's Freight Mobility section.
Kevin Ballmer, MERP student, Conway Transportation Services.
Brent Freeman, ODOT Traffic Counting Program.
Eric Anderson, Oregon Department of Transportation, Traffic Counting Program.
Jennifer Dill, PSU.
Ron Anderson, David Evans and Associates, Transportation Manager.
Christian Snuffin, David Evans and Associates, Traffic Engineer.
John Hazlett, future urban planning student.
Kathleen Kincaid, environmental studies student at Portland State.
Tim DeBoer, I'm a senior in the Civil Engineering Department here at Portland State.
Derek Jager, Porter Portland Research Analyst.
Kristen Tufte, I'm a researcher in computer science at Portland State here.
Suman Tasneem, graduate student, Civil and Environmental Engineering, Portland State.
Zach Horowitz, first-year master's student in Civil and Environmental Engineering.
Ali Al-Hawai, master civil student in my last term.
Okay, well, thank you all for coming today. We are embarking on a fairly ambitious, fairly exciting project for the region, the goal of which is to collect specifically O&D data for truck movements and enhance the region's truck count program that currently goes on sort of on an ad hoc basis and make it a more formalized program.
What's O&D?
Sorry, origin and destination. Something we don't have.
We have a civilian.
First of all, talk a little bit about why freight is important to the economy and why we should care about freight. Transportation and distribution has become something of a niche industry for our region, has been for quite some time because of our geography. We're closer to inland markets than, say, Puget Sound is. We have better access to inland markets because we have the river grade access through the gorge for both rail and truck. We have a multimodal transportation system. We have air, we have ocean, we have rail, we have barge, we have the whole gamut. And it creates jobs and generates income. About 1 out of every 10 jobs here in the metro area is directly related to the transportation and warehousing industry. And if you look at the stats from the employment department, it shows that the annual wages and salaries in that industry tend to be above statewide averages. Freight transportation dependent businesses in Oregon account for about 60% of jobs here in the state. What that means is industries such as construction, retail, manufacturing, those industries that rely on transportation to get inputs to their facilities or final product out are very dependent upon transportation and account for most of our jobs. That's sort of why we on the public side of the equation care. Now looking at why the private sector really pays attention to freight transportation, a recent Penn State University study showed that about 20 to 25% of a product's costs are in logistics. And so that's why a lot of firms are really looking at their supply chains, at their transportation practices to see how they can drive cost out of their corporations. And one of those ways you do that is with just-in-time or just-on-time delivery, and this last bullet talks to that. You can see that what used to take about a month 40 years ago is down to 2 or 3 years today. That doesn't mean there's less in terms of warehouse space, it just means there's less time spent in a warehouse for a given product. But again, getting something from its source to its final consumer is very important and reduces holding costs, and that's why the private sector really focuses on this. And I have an example here of a local company who is very dependent upon freight movement. It's Columbia Sportswear, and I'll walk you through sort of how their product comes into the region and then goes back out again. For those of you who weren't aware, Columbia not only is headquartered here in the Portland area, but they have their only national distribution center for apparel here in Portland. It's out in Rivergate near Terminal 6. So what they do in this first slide is they import. They're primarily an import company, and they bring in apparel, footwear, and accessories by ship from Asia into T6, and also to Port Sip and Puget Sound, and then it's trucked either from Terminal 6 or from Puget Sound down to Rivergate to the distribution center. They also use air sometimes for things that may have a quota, for samples, for material testing, things like that. Those shipments arrive at PDX and also up at Seattle Tacoma, and they also move by truck to Rivergate. And the next slide, now that things are at the warehouse, a number of things happen there. They unstuff all their ocean containers, they unpack the air freight, and then they sort all their products by SKUs. And SKUs are called store-keeping units. And depending on how the company defines it, it could be, for example, a red toothbrush with hard bristles has one number, a green toothbrush with hard bristles has a second number. That way they know exactly what color, what size, and what the inventory situation is. And so they also organize their warehouse like that. Once all of the SKUs for a particular customer are now in the warehouse, they can go ahead and pick that order, put it in a domestic container, and ship it out. And the customers tell them exactly how they want that done. It's not something that Columbia typically has much discretion over. And so then they pack it. And just as a side note, which is an interesting thing here, the Rivergate Distribution Center also handles returns or reverse logistics. So a customer is not satisfied with the product or there's a defect, it will come back into this distribution center. Moving on to the next stage, which is reloading, as things get ready to head out of the region. On the air side, freight forwarders will take those shipments and take them to a reload facility where they'll move from a truck into air containers or be palletized for a freighter for air shipment. The LTL, the less than truckload carriers, will come to the warehouse in their pickup vans, pick up the product, take it to their hub, and mix it with other loads for the same city. In other words, they may mix it with a Fred Meyer or somebody else who's shipping to the same city as Columbia because Columbia doesn't have enough to fill a single truck for that particular destination. And so there's this sort of intermediate step that happens, but there's truck movement to and from those facilities as well. Finally, the product does leave the region. All other product lines either move out by air or by truck. If it's by air, it's primarily out of PDX using one of our integrated carriers for domestic movement. And they use a lot of less than truckload. Again, they typically are shipping all over the country and do not necessarily consistently have a full truckload for any single destination. Memphis, Denver, Atlanta, Boston. So they use LTL because they can get their shipments more frequently that way by using smaller size shipments and use less than truckload. On occasion, when they do have full truckload moves, those truck lines will come directly to the warehouse in Rivergate, pick it up, and go straight out of the region. And this slide talks about why we need a multimodal transportation system. As you saw from the Columbia example, they use water, they use air, they use truck. But other commodities also use multiple modes. And what you'll see from this slide is that there's no product on here that uses only one mode. And for example, with all air shipments that come in and out of the airport here in Portland, there's a truck trip attached to that. There's nothing generated and nothing consumed at the airport. And so there's always truck movement associated with that. So when you have air volumes increasing, you have truck volumes increasing. And again, part of this is strictly based on need, but part of it also is a competitive situation where you have truck competing against rail or ocean competing against rail. It gives shippers an option. It also allows for price competition and gives them better access to markets. So we try to make sure that we have the infrastructure in place that allows this to happen. So what happens if we don't? First of all, unreliability forces businesses to adjust. And before I go on to those sub-bullets, I want to make a point about reliability. What we've heard from our customers at the port is that being able to predict how bad the traffic is going to be is far more important than the fact that there are going to be delays. If they know that every day it's going to take them 45 minutes to get their product to the airport from the west side, that's fine. If it goes and is consistently then an hour and 15 minutes a couple years from now, they can plan for it, they will allow for it, they can deal with it. They don't like to, but they can. What really bothers them and makes them pay penalties for late delivery or increase their costs is when today it takes 45, tomorrow it takes 2 hours, the day after that it's maybe 55, they just don't know. So what they have to do, and this first sub-bullet talks about, is allow extra time for these pickups and deliveries, which either results in less production time or moving their production cycles so that workers have to start at 5 or 6 in the morning instead of 7 or 8, because they have to have things ready to go in time to get to those, either the airport or the truck terminals. And there are many companies, and I think Columbia is probably among them, where they will pay a penalty if they do not get their product to their customers on time. So it's not just that they may lose future business, they also have a direct monetary penalty for not delivering on time. Something that may not be intuitive to most of us, but when we talk to some of our customers, we learn they will also put extra vehicles on the street during highly congested periods to meet the demands of the transportation system and their customers. So, for example, say FedEx or UPS or one of the long-haul trucking companies will put extra trucks on the road because each individual truck can cover less territory because of more congestion, greater unreliability in the transportation network, which sort of only compounds the situation because you're adding more congestion. And finally, they end up doing things, they adapt, and they do things that they don't want to do and things that we don't want them to do, such as using neighborhood streets to get around particular problem areas. Clearly, we as residents don't want them there, and the drivers really don't like doing it because neighborhood streets aren't designed for truck movement. They don't like to have to compete with a lot of pedestrians. The turning radii aren't that great, but they do what they have to get to the terminals on time again, because in many cases, they have some sort of penalty if they don't. Finally, if all this gets too much and all these adjustments start costing them too much money, they may simply relocate out of the region and take the jobs with them. So what we're trying to do here in the region is really understand what the needs of freight movement are, collect the data that we need or the politicians need to make more informed decisions, and then invest in infrastructure improvements at the right places at the right times to benefit freight movement. And what we've done is sort of taken a two-pronged approach to this. And the way I look at this slide is really what we're trying to do on the public side of the equation is understand what our customers need. We get out there and we talk to them. We try to get information about what they do and how they do it, what their needs are, and then address that. The first prong is through research, and that's through our commodity flow forecast. We collect information about freight movement, identify how much of what kinds of commodities move to and from the region, how they move, and then describe the interrelationships between the modes. Again, as I mentioned earlier, every time you have an air shipment in and out of the airport, you have a truck movement to and from the airport. Then there's intermodal shipping of containers coming downriver from Idaho, southeast Washington, northeast Oregon that moves from barge to ocean. You have traditional maritime intermodal where it moves from an ocean vessel to rail, and trying to understand how all of this works and if there's a truck trip in between. Sometimes there is, sometimes there isn't. And I'll come back and talk about the planning part of it second. But the approach that we are using is recognized nationally as being very innovative. Not many other regions have done what we have done here in Portland, Vancouver. So first I'm going to talk about the commodity flow forecast, which will ultimately get me to this origin destination survey and truck count project. You can see who the sponsors were. It truly was a region-wide project. And we have baseline data for 1997 with forecasts of volumes out to 2010, 2020, and 2030. We have data on the dollar value and the tonnage of the freight that moves to, from, within, and through the 6-county metropolitan area. What we learned is that freight volumes are going to double between 1997 and 2030. And just to sort of put that in context, my guess is the transportation system capacity isn't going to double along with it. So there's some decisions we're going to have to make somewhere along the way. And this average growth rate, about 2.1%, is faster than population growth. Yes?
The question I had was, is this projection not assume any constraining capacity of any facility?
Correct. Assume whether the capacity is going to be
port or road system or anything. Okay.
Yeah, just based on the need of freight and employment patterns. Yes, exactly. Which is sort of to the point we want people to make decisions about where to invest and whether to invest in the transportation network to accommodate this. And as I said, about 2.1% growth rate for freight, and I think it was a 1.6% annual growth rate for population during the same time period. Very quickly looking at what's moving through a region. On a tonnage basis, it's the big bulky stuff that leaps to the top of the list. It's petroleum, minerals, grains, wood products, aggregate. And the 8 largest categories comprise about 3/4 of all tonnage shipped here in the region. Looking at our fastest growing commodities in terms of tonnage, this is what's shown on this slide. The 2 categories that are highlighted in green there were also on the previous slide as among our largest, so they're both large and very fast growing. And that far right column talks about the modes that are impacted by this growth, and you see it just about on every single one of them, truck is there. So understanding, again, how freight moves on our road network is going to be very important for this region. But it's also important to look at value, because if you remember from the earlier slide, you didn't see things like wafers or chips or anything like that. A lot of our high-tech product is very small, very lightweight, so it's not going to show up anywhere on a list of heavy commodities. So you also have to look at the value of commodities. Also interesting from this is our number 1 commodity in terms of value is textiles, leather, and other apparel articles. Well, you know, Nike, Columbia Sportswear, Fred Meyer imports a lot of that kind of product too, which is very valuable. We have vehicles, again, grain simply because of the total sheer volume of what we've got, and then you start seeing some of the electronics and precision equipment that we produce here in the region. But again, if you don't take that into account, you might assume, well, planning for access for freight to the airport probably isn't very important. Well, here it shows that it is, and if you consider the jobs that are supported by that, that further makes that statement. Looking again at modal shares, I hinted about this earlier, that trucks are really important. Well, there you go. 63% of all tonnage moved by truck in 1997. That's going to go up to 72%. Air is actually growing the fastest, but then again, you're on a small base, so that number is a little misleading, but still important to understand. And the final point I want to make is barge and ocean lose share, but they're still growing. Just because you lose market share doesn't mean you're shrinking. It just means you're not growing as fast as others. And that's a point I want to make, especially from the port, that we're not going away. The demand for barge and ocean service is still going to grow, but just not as fast as some of the other modes. Implications of the forecast. I think from those numbers you can see that freight movement is going to be very important for the region's economy for the next several decades and beyond. Again, the capacity is not going to increase at the same rate as the volume of commodities is going to increase, and so we need all the modes to function effectively, because if we don't have enough rail capacity or it's not functioning, it's going to default to truck. If we don't have a pipeline, for example, we had an explosion a couple years ago in the pipeline that delivers petroleum from Puget Sound refineries down to Portland. That had to move on another mode because it was inoperable. And fortunately, we had capacity in the ocean and barging system to accommodate that. If not, it would have moved over the road. You can imagine how much petroleum comes into the region on a daily or weekly basis and how many trucks that would have taken to move that product. So again, making sure we have all the modes functioning effectively is very important. On the planning side of this, Metro has developed a regional truck travel model. Again, very few other regions have such a tool to try to understand when and where trucks are going to be moving in the future. They use it to project freight movement on the road network, identify where congestion is going to be, look at possible solutions for it, and then set priorities for transportation investment. And it's all based on the commodity flow forecast. So they take the commodity volumes rather than employment to understand the number of truck trips and allow the commodities themselves to help them understand the type of vehicle that's involved, the load factor, and the time of day. And on load factor, one of the points I'll make here is that with LTL carriers, truckload carriers, they really try to fill those trucks as best they can because they generate more revenue that way. I went out to the Portland Air Cargo Association and presented the same presentation to them, and they raised their hand and said, well, you know, we don't operate like that. We're about being on time. We have to get back to the airport on time. So we're more concerned with getting enough trucks on the road and getting them back by 5:30 or 6 at night rather than filling them. Filling them is less important than being on time. So again, the types of commodities really do drive the numbers of trucks. And looking at the logic, Metro has a very successful model for predicting the movement of passenger cars, and this is a little more complicated, which is why they have developed a separate model that they tie into their main model. If you're a shipper, you can send product out to local distribution. You can send it directly out of the region. You can send it to a marine terminal, an airport, a rail yard, or a truck terminal directly, or it can go through a reload facility where it gets loaded into a container or gets palletized first. So there are a number of choices that Metro has to try to model and understand to make the model work right, which is one of its biggest challenges. And one of the outputs or types of output you get from this is a 2-hour truck percentage for the PM peak. And what this shows is that as a percentage of total traffic, trucks aren't that much, but they're growing substantially. On 84, 75% increase between 1997 and 2020, fairly healthy growth, even though they currently are only about 3.5% of total traffic. So again, probably you look at that and go, it may not be that important, but again, consider what's in there, the jobs that are behind that, and then how fast truck trips are growing. Despite this, there are many data gaps, and that's one of the things you'll talk to anybody who's involved in understanding freight movement is the fact that there's not enough data. We don't have what we need to understand everything as well as we want to. So here are some questions that we get asked that we just can't answer today. What commodities and how much of them are moving across the interstate bridge every day? That was a really big question in the first couple of phases of the I-5 Trade Corridor project. But we don't know. We don't have the answer to that question. The federal government, even though they collect freight data, doesn't have data that will answer that question. How much cargo moves from Washington County to the airport every day? We'd love to know that, but we don't, and there's no data that will support that answer. What time of day are there the most trucks on the road in Clackamas near all those distribution centers? Again, time of day, we'd love to understand that, but there's no data available for us to use. So that inspired us to fill those gaps with this project to collect origin destination data, do more truck counts, and refine our understanding of how trucks get routed here in the region. So what we are doing is a freight data collection project. Again, it's regional in nature, participation from both states, both MPOs, both ports, cities, and counties. And we broke it into 2 phases. First, we looked at what does the region need. We asked questions to understand what kinds of things does the region need to know? What kinds of data does it think that it needs? Then we hired Cambridge Systematics to do the analysis for us, and they took a look at what we said we needed, the kinds of questions we needed to answer, married those 2 things together, and came up with a menu for us of the kinds of information we would need to collect to answer the questions we really want to answer. We ended up talking with about 50 different firms, agencies, and organizations, both public and private, here in the metro area. We conducted focus-style group sessions with them and asked them the kinds of questions they want answered or they get asked themselves, or the kinds of data that they think they would need to address the issues they feel are most important. I'll whip through these pretty quickly, but here is a list of the firms or the types of organizations that we brought into these focus group sessions. Again, public and private, as well as nonprofit, and folks from across the Columbia River as well, so that we could include Clark County. And what we learned, for the most part, was that no single organization is the same as any other. Everybody had their own list of questions. We kind of brought them down into categories. One is, what is the value of freight for economic development and business development projects? People trying to understand how important is it to companies, how important is it to the economy? Why is it more important if trucks are delayed than regular passenger vehicles? Trying to understand what is the cost of delaying a truck. Why isn't it possible to use rail for more freight? Can trucks be pushed to off-peak times, and can truck-only lanes be developed? What is the capacity for other modes? How do trucks get to their truck terminals? Where does freight consolidation occur? What % of freight passes through Portland but is being shipped out of other marine and airports? And what % of activity at the airport are actually truck moves? In other words, if we don't have that particular airline calling here, but they collect cargo here, you have a truck coming in with cargo to our cargo facilities, and another truck coming in, picking it up, and taking it to the airport where that airline actually serves. So the airport begins to function a little like a less than truckload terminal for some freight movement. And again, these are a wide range of questions, and we're not going to be able to get all the data at once to answer all of them, so we began to prioritize what our data needs were. Trying to understand truck rail diversions. When does that occur? When can we get that to occur if we want it to? What are our backhaul opportunities? Typically, we've had more truckloads coming in than going out. So the trucking companies have been fighting each other using pricing as their main mechanism to attract loads to haul back out of the region, which has great advantages if you're a shipper moving product domestically outbound from Portland. But we haven't had good data on that for almost a decade now and want to understand, is that still there? Is that going to continue to be the case? What is the possibility of using freight for intra-city moves, such as the movement of logs from the fringe of the metro area into the center where they can get reloaded and put on ships or trains or trucks, rather than having a truck bring that into the middle of the city? Fine-tuning of our commodity flow data to reflect known patterns, particularly for north-south data. This really focuses on the rail moves, trying to understand what is the north-south rail market, how much of the capacity is being used, if there's excess capacity, why isn't it being used, and what impact would that have on traffic on I-5 up and down through the state of Oregon. More truck count data. There's not enough data being collected, and it's being collected on an ad hoc basis by many jurisdictions throughout the region. We're going to try to coordinate that if we can and figure out exactly how many trucks there are, where they're going, and see if we can't coordinate that. And finally, understanding through trips. What's moving through here but never really stops. So what we've ended up doing is having three primary objectives for our second phase. One is the collection of origin and destination data for trucks. Right now, when Metro models where trucks are moving, they're using employment and other indicators to figure out what industries are located in which parts of the region, what kinds of inputs they need, what kind of products they produce, and then using our commodity data to link that up. What we really want to know is where are trucks actually moving. Their algorithms at Metro are very good, but they would prefer to have actual origin-destination data, be a little more accurate. Again, truck counts, understanding exactly how many trucks are on the road, on which segments of the roadways, and then routing decisions. Understanding, we may know where the origin is, we may know where the destination is, but we really truly don't understand how do they get there. And so understanding those route choices, because, for example, the city has its designated freight routes, and one of the things that we heard from the city who interviewed them is it would be nice to know if what we've identified is actually what works for the truckers, if that's what they're actually using, and match that up. And if not, why not? Timing, we had hoped to be underway a long time ago, but through a series of things that came up, we just now are getting to our kickoff meeting in a couple of weeks. We hope to have initial data available by spring, though I think for some of our project partners who have specific data needs, we'll have data prior to that. What we are doing is we're going to do the surveys and the origin, truck counts on a quarterly basis. So we have data from 4 different quarters rather than doing it all at once. And so it will take some time for us to get that data aggregated. And we're hoping to have this completed by the fall of 2006. And here's who's sponsoring the second phase of the project. It's about $730,000. Metro, ODOT, Southwest Washington RTC, WashDOT, Multnomah County, and the Port. We also, on our project team, have representation from Washington County and Clackamas County, the City of Portland, the Port of Vancouver, and a couple of others who have expressed interest, so that we'll get their input on this project as well. One of the things that we're able to do with this project that we're very excited about is leverage some other research that's already been done. Through ODOT's research program, they contracted with Washington State University 2 or 3 years ago to identify the most effective ways to collect data on truck movements. And what they were able to do is test a number of different methodologies and survey instruments to see what worked best. And what they were able to find was that surveying truck drivers at weigh stations is fairly effective because the truck drivers have to pull off at the weigh station anyway. And so they do have some spare time and are willing to answer questions. And that's a technique that the university has had great success with in the state of Washington for all of the freight work that they've done. But what they did differently this time was actually try to survey truck drivers at freight terminals and warehouses, something that hadn't been done before. And we didn't know exactly how well it would go, but it was interesting. I was actually on site at Terminal 6 when they did the test there. And most of the truck drivers chose to participate. It was totally voluntary. And most of them were so excited about someone asking them about what they were doing and where they were going that many of them actually hopped out of their cab and started pointing out to parts of their truck and explaining the truck to the survey takers. Well, this is where we do this, and this is how this works, and when we get rid of this, this is what we do. And so we found that that actually was fairly effective, not only in getting data, but also in keeping the terminal moving. That was one of the concerns we had at the port was, can we stop these trucks, ask them these questions, and keep from having our terminal getting backed up? And we did. So it worked out pretty well. When you have a warehousing company, such as Oregon Transfer, who's very excited about the project and willing to participate, those surveys worked out pretty well, too. They were able to get the truck drivers at the warehouse when they weren't busy because the truck was being loaded or unloaded. They had some spare time and could answer a few questions. And so they were able to get data there. The quality of the data for some of these surveys varied, and depending on what the region wants to do with the information, some of it will be just fine, others it won't be quite detailed enough because the drivers may or may not know all the detail that would be desirable, say, for modeling purposes. But for policy questions, I think we can get some good data out of that. The other work that's been done is a project that Oregon State University has done with a grant from US DOT to study the application of GPS technology to collecting truck trip information, working with Metro and with the port to do this. And what they did was they found a couple of trucking firms who were willing to have GPS units placed on their cabs, and they tracked them for I think a span of 2 or 3 weeks and then moved them to another truck. And they did this for the span of a summer. And were able to get very accurate data on exactly where that truck was, combining the GPS information with Metro's very detailed mapping system. They were able to map the exact roads that were being used by these trucks, what times they were there. Very accurate, and again, taking advantage of some grant money. And I'll show examples of this now. This is what they were able to find. This was a specific trucking company. We don't know who, but it was one company, and this was the series of routes that we're able to trace using the GPS equipment. Fairly well contained. Each truck had its own area. And here is another one. And I don't know if you can see it, but there's a dark purple that seems to go everywhere in the region. That is because they had a low-level truck with its own lift capabilities, because some of their customers had dock-high doors but didn't have any way to get the freight from the parking lot level up to that dock. And so they required the trucking company to have a lift gate at the back that would go up and down to move that. So that truck had to go all around the region to serve those customers. They were able to figure out when the truck was actually stopping for delivery. They made up their own rules as to how long a stop was and then divided the data that way. A delivery stop was something along the lines of 5 to 15 minutes, something not terribly long, as opposed to a half hour, which is probably a break or a lunch or something. But they were able to identify this and then go back and check the trucking company's records and compare, and they were almost dead on every single time. So they're able to tell us not only on which roads the truck traveled, but exactly where they stopped and for how long, though for modeling purposes, the how long isn't quite as important. And again, the routes between different stops, the kinds of detail you can get from the GPS is really amazing and is probably one of the most efficient ways for collecting truck data. We can also look at Metro's transportation analysis zones and see truck traffic by those zones. And you can see out by the airport, it's fairly heavily traveled in terms of numbers of trucks. And again, without GPS, I don't know how we get that data as quickly or as easily. And density by street, in other words, how heavy is truck traffic on individual streets. And the lighter the color, which is sort of counterintuitive to me here, lighter the color, the heavier the density, the darker the color, the lighter the density. But nonetheless, showing which roads are heaviest used for trucks, at least for the 2 or 3 firms in this sample. Unfortunately, due to some conflicting public sector government regulations, we're not able to get OSU to do all the work we had hoped they could do in the second phase, though they did get a second round grant from DOT, and we will be matching that with local money to get them to do some data collection. So we'll have some GPS data as a part of the second phase, but not as much as we originally had hoped, but that will be a start. So wrapping up my presentation, talking about what we're doing and why we're doing it, The economy really does depend on the ability to move freight, both from our large distribution transportation industry to also manufacturing. And Oregon tends to have a higher concentration of employment in manufacturing than most other states. Freight volumes, as I mentioned, are going to double by 2030. Funding is limited. Our transportation system is not going to double its capacity, so we're going to need to prioritize our investments and figure out when and where to make those investments. And to do that, we need to understand when, where, and how freight moves. And because data is not available that is specific to the region, at least at a national level, we have to do it ourselves here in the region. And we have become a leader in doing this. And by having the second phase project to collect the origin destination data and the truck count data, we're actually leveraging the investment the region has already made in our commodity flow forecast and in the truck model development by doing this. Again, we know what's moving to, from, through, and within the region, but we don't know exactly where. We don't know exactly what time of day, and we don't know what routes they're using. But we do know, as I said, that sort of the overall flow, this will give us the detail that particularly Metro can benefit from. And finally, our goal with all this is by doing freight research and continuing to do freight research, we're able to make better decisions so that we can make better investments and have that result in a better economy for the region. That's it.
Questions? I want to remind people to use the microphone.
Yes.
One of the questions I have is how much do labor laws and longshoreman rules and all that affect movement of freight, assuming that there's a lot of constraints there?
There are, and that's one of the big topics right now nationally is can you start moving freight at off hours, both at port, airport, and rail facilities as well as big retailers, because that's another point of congestion is big box retailing and all the trucks that it generates. But the perfect example is there are either union or other regulations in place that sometimes will preclude that. I know a lot of the retailers would be happy to take freight at 2 or 3 in the morning. The problem is they have to pay people to be there to do that. And sometimes the union regs about how long or when employees can be there. In other cases, it's a matter of actually finding people who are willing to do that work. And then again, at the ports, it's an issue of when can you have the gates staffed, when can you have the ships unloaded. So some of it is, unfortunately, beyond the control of local government or even individual companies.
Follow-up question. It's my understanding that some of the breakdown distribution centers may be also governed by labor laws in terms of whether you have to use longshoremen to break down a truck or whether you can use cheaper labor?
There are certain rules like that. Anything in Portland, I believe that the rule is if it's on the waterfront, it typically is longshore, but farther away from the waterfront, it is not. But there may be other unions involved as well, which would have their own separate rules for work purposes.
When you talk about having a better economy, is there any way or has it been quantified how much this data would help impact the economy in a positive way or what the value is?
I would love to know the answer to that question.
Okay.
So you can figure out a way to do it, let me know. Cause most of what we can do is just very indirect anecdotal information. And that's, again, nationally, that's a big question is how do you quantify the benefit of either freight research or investments in freight facilities to a better economy?
Any feelings of where it might be going?
In terms of trying to link, I think the federal government, U.S. DOT, is very interested in doing studies to understand the impact of investing in freight facilities or improving the highway system, and then what happens after that. Do you create jobs? Do companies move into the region or wherever that improvement was made? And does that create jobs? And what does it do to congestion? And so that's, I think, an initial step is just trying to understand the link between investment and the economy, and later between the research, the investment, and the economy, sort of taking steps backwards.
What are the main causes of freight traffic doubling by 2030?
The main cause is partially population, and partially the role that we play sort of in the national transportation system, because a lot of the freight that we handle neither originates nor is destined for here. For example, grain is a good example of that. A lot of that is grown in eastern Oregon, Idaho, Montana, the Dakotas. Grain is forecast to grow, especially as China increases its demand. So there is freight that's coming through the region that we're not producing or consuming. Mineral bulks, the same sort of thing. And then again, even though our population growth rate is about 1.6% during this time period and freight growth is 2.1%, because we are a coastal region and we are a major distribution center for the United States, the growth rates in other parts of the country also come into play because they demand products such as autos and consumer goods. And so it's sort of a compilation of a number of different things. Jennifer?
I've often heard that one of the reasons there isn't good freight data is difficulty in getting either freight companies or the manufacturers or whoever, to be willing to give that information. Some concerns over secrecy and trade and competition. Do you think that's much of a problem, or is it just a problem with certain types of industries or certain types of freight or certain information?
I think that's a huge problem. I think that explains exactly why there's not much data, because there is this fear of proprietary information getting out. And also because of the advent of third-party logistics. A lot of companies, the shippers themselves, may not know the answers to questions that we would ask them because they've outsourced that to another company. And then those companies have confidentiality issues because they don't want to release their client's information without permission from their client. And so that getting data from those companies is crucial. The federal government does do a commodity flow survey every 5 years, and it's mandatory if you're a company that receives the survey. It's like the census. You have to do it, and it asks fairly detailed questions. But the scope is so small that they have to suppress a lot of the data because by knowing it, you can guess who the respondent was, particularly at a metro level detail. And so trying to figure out a way around this is really the key to getting better freight data.
Did that come up at all when Washington State was doing the interviews with the truckers? I mean, did the truckers themselves just freely give out information, or did they ever question, oh, should I be telling you? Or?
I don't know that they ever questioned that. I think they just made their own decision, I am or I'm not. There may also have been some communication with the trucking companies in Washington letting them know this is going to happen. We plan to do that. We will go to the Oregon Trucking Association. We're planning on also going to the Portland Freight Advisory Committee, letting folks know that we are going to be doing these O&D surveys and these truck counts, and not only just to get them to be aware, but also maybe to get them to endorse the project and have their members and friends participate in this.
So I was wondering if there's a significant seasonal component to freight movement, and will you be collecting data over a long enough period to see that?
Quick answer is yes and no. Yes, there's very definite seasonal differences, and it varies by mode. The ocean mode tends to peak starting very soon, actually, with the movement of Christmas-type merchandise, seasonal goods for the holiday season. That then comes over, and then it's the trucking industry who gets hit because it sits in warehouses, and now it's time to deliver it to stores. And then finally, at the end of all this, when supplies are getting low and the rest of us are all shipping our Christmas packages, the aviation industry gets hit with their big splurge. But no, we're not going to be able to collect enough data, even though we're doing it 4 times a year, to understand the seasonality, other than to know that there is seasonality. What we don't truly understand is, there are more trucks on the road during peak season. What happens to them during the rest of the year? Maybe it's the fact that during peak season they're loaded both directions, and the rest of the year they're only loaded in one direction. Hopefully we'll get there, but probably a later phase of data collection.
I have a curiosity about counting trucks. In terms of, and this may be more a question for an ODOT person, but when the traffic slows down on a freeway, how do you do class counts in congested conditions?
I'll defer that to ODOT, yes.
When the speeds are slower or more variable, the machines that count do have more trouble with that. They all of them have lower limits on the speeds that they can work with. And for instance, the hose shortcut counters, you get below about 30 miles per hour and you're completely out. We are installing some new counters in the next 2 months. We'll be able to answer one of your questions about the Clackamas Highway by Fred Meyer. We're going to install a permanent classifier on that highway as well as on US 26.
Excellent.
And those machines are using loops and piezos, and they can take a wider variety of inputs at the lower speeds than for instance, the hose tubes can. And so we will be coming up with some seasonal and time of day type data here, hopefully soon. But of course, it'll take us at least a year to get a year's worth of
right.
seasonal
Yes.
variation.
Yeah. That's what we're facing too. Another method we're going to try to use too is where we can is use video counts, so that you'll have someone just watching video counting trucks, so that you don't have the same issue of speed. Yeah.
I had a couple of questions about freight shipment time. You said that in the last 50 years we've seen average shipping time go from 30 days to 3 days.
Yeah.
And then,
Roughly.
And then in the next 25 years, freight shipments volume's going to double. Are there projections on how that increased freight is going to affect our average shipping time? And also, do you think it's technically feasible to even improve on the average shipping time at this point?
My personal understanding of what's going on leads me to believe that improving on 2 or 3 days is probably going to be very difficult for a number of reasons. First of all, as you mentioned, freight's going to double, and so how can you deal with that on a network that's also not going to double? But there's also a trend towards more frequent, smaller shipments, which also creates additional traffic. And so how companies, either the shippers or the transportation companies, are able to manage all of that and improve on 2 or 3 days, I would be surprised if they could do that. Where it's headed, I haven't seen any projections. No one has raised that as an issue, but I think that's a really interesting question. Looking ahead, if this is going to happen, we're going to have this in terms of volume, but our capacity is going to stay here. What really can we expect in terms of delivery time? It's a very good question. Rob?
Scott, just to follow up to that one, do you think that more frequent, smaller questions implies a demand for smaller vehicles to carry those loads?
I think so, at least in the urban setting, because you'll have more pickup and delivery. It sort of gets back to the LTL question is, can you fill up a large truck for a single destination, and so that your long-haul move, say from Portland to Kansas City, may be in a large truck, but in the metro area, because you're going to have many shippers with lots of small shipments, you may need smaller vehicles in an urban setting more than you have in the past. That's what I see, at least.
In terms of the funding for this project, is there ever an attempt to get funding from the private sector? I would think it'd be good for businesses' bottom line.
We really haven't done that. That's an interesting idea. We try to get their involvement through volunteering for things, serving on project committees and things like that. That doesn't always go well. We try to get them to volunteer their data and give their data to us. That doesn't always go well either. That's probably the biggest area of improvement I think we in the public sector need to make, is communicate to the private sector what the value is in us doing these sorts of things, because to them they go, okay, well, we don't see it. And part of that is because this element of time, which is very different between the public and private sectors. We need to know 10, 15 years out what things are going to be like so we can build a bridge or expand a freeway. The private sector is looking at what's happening next quarter. And 15 years from now, they're not even concerned about. So we have a little bit of mismatch in time. But I think things are getting better. You're beginning to see more participation in committees by private sector firms, and for them to step forward with ideas of how to collect data. So it's getting better, but we're far from where we need to be.
I'm wondering why we are assuming that growth is always a positive outcome, and it's something that cannot be avoided in processes like freight movement. and why we aren't putting more research into sustainable practices and minimizing these sorts of things that will have a big impact on our community and other communities.
Well, part of what we did with the commodity flow forecast is, as Rob pointed out, was leave it unconstrained in terms of capacity so that the region could decide, what do we want to do about this? Anything? Do we want to accommodate all this, or do we not? And if we do or we don't, then make decisions based on that. In terms of sustainability, part of the issue that we find is that an area like Portland is not very self-sufficient. We don't produce a lot of the goods that we consume here. A lot of the consumer goods are not produced here in Portland. We have to rely on other areas. One thing we have looked at, though, is trying to preserve industrial land around freeway interchanges and other places where we actually will get better use of the land and the transportation network and reduce the number of vehicle miles traveled and the number of truck trips to and from the center of the city. By not planning other metro areas, I've had the experience where you have a center city and then residential areas, and out at the suburbs you start to have your distribution facilities, and as those grow they start moving farther and farther out, and you have more and longer trips in. So by paying attention to land use, we can try to make the freight industry more sustainable in that respect. And is growth always good? I think that's up to the individual. A lot of this is driven by making sure that the economy is also sustainable, and we can support the industry that we have. But those are good questions. And trying to make freight a better neighbor for the environment is something that's also, I think, on the radar screen at USDOT. Yes?
Was there any discussion within the focus groups on how it might be possible to shift freight from truck travel to one of the other modes, such as rail?
Well, there's a lot of interest in this, and to see if we can't get diversion from one mode to another, which gets back to my point about making sure that we have adequate capacity in all the modes, because if you don't, then you certainly can't do that. Part of it depends on the distance, for example, for rail. If you're less than 500 miles, it really isn't as economical to ship by rail as it is by truck. Over that, then yes. So trying to understand where are our markets and do we have rail service and rail capacity to serve those markets. If the answer is no, then we go, aha, then there may be an opportunity for us to take some of this truck freight, which really is rail freight, and put it back on rail. In fact, as a side note, through ODOT's research program, starting next fiscal year, we're going to be doing some research on short lines here in Oregon to see if there are some things that can be done to make improvements so they can handle the heavyweight cars that the major lines use, so that we can move product from rural areas into consolidation points in urban areas by rail rather than road. Because it's both a long-haul issue and sort of that short pickup delivery issue as well. So there's a lot of interest in it. It's a matter of how can this be done. And also, of course, is up to the shipper, too, and the mode they want to use. Though the interesting thing about one of the trends is a lot of shippers are caring less exactly about the mode that's used. They're more concerned about the cost and the time. If you can get it to point A, in so many days, I don't care whether you fly it, you drive it, you put it in a train, just get it there. And so there may be more opportunity for this kind of thing in the future. Yes.
I work for one of the national LTL companies here in Portland. In fact, I work in their IT department, and I have to say that there really, at least from our perspective, hasn't been a lot of attention paid to infrastructure issues, which of course is the domain of the public sector. I can't stress enough how important it is for your project to have some attention paid to educating the folks in the private industry, trucking companies, rail companies, what have you, because there really isn't much knowledge, I think, and or a belief that the correlation between getting business done and the facilities that they use to get business done, it's very, very, there's a huge disconnect there. So I would strongly encourage you to continue your efforts to reach out to trucking companies here in the region.
So is it more they're taking the transportation system as a given and just assuming that it's going to be there, or taking it as a given in terms of we'll plan around it rather than understanding what it takes to make the improvement?
There's very little knowledge of the process.
Okay.
And so, I would just say that there's a need for both, I think, private industry to learn more about the process of the public sector and vice versa.
Okay. That's a good point. Yes.
Do you know if the Connect Oregon program that's proposed contains some money or some thoughts to spend some money on collecting freight data? And in general, do you feel that that program, the $100 million, is going to go some distance to improving freight transportation in the region?
Yeah, I think that the money that's being set aside in Connect Oregon will help the region tremendously. It's a focused effort that I don't think the state has had before, paying attention to freight movement. The question is whether there's money there to collect freight data. I don't believe that there is. ODOT, you heard of it? I think it's all infrastructure-related money, which is also sorely needed. But as best we can, we'll help them by giving them what data that we have. Yes.
What's a truck?
What's a truck? Oh, that's a really good question. What we have done to date is measure trucks that are 26,000 pounds in gross vehicle weight and over. And so the smaller, what we're trying to do is, because you get into the issue of what's a truck versus what's a commercial vehicle versus an SUV, and then you get down to the car. And so, excuse me, for Metro's purposes, we have looked at that gross vehicle weight as sort of the cutoff. And so it's the plumbing vans and the florist vans aren't included. Should they be? Probably. But again, it gets back to scope and money and time. But that's what we're focusing is on really the big rigs, so to speak. Chris.
Question from one of our web viewers. Has there been a history of any company leaving the Portland area because of congestion and freight transportation issues that you know of?
Directly because of freight, not that I'm aware of. But we haven't had the issues as badly as we're going to have either.
Has the just-in-time delivery concept adversely affected rail freight movement? And why are people in this region not trying to improve rail freight movement for short distances, just to keep freight trucks less in the highways and reduce the wear and tear and the maintenance cost, and just use the infrastructure that is available on the railway?
Answer your first question on just-in-time in the rail industry. I think initially just-in-time had a very negative impact on the rail industry. I think that industry had a reputation for being not particularly good in terms of delivering product on time. It was also not a fast-moving mode of transportation. But over time, I think that has changed quite a bit because you've seen a lot of trends towards intermodal transportation with truck, where you take a truck to a rail yard, put it on a flatbed rail car, and it goes the long distance. And so because the trucking firms are very sincere about delivering on time, they have made the rail companies deliver more on time. And so I think over time, that's improved for the rail companies. And so just-in-time is no longer a threat, but probably something they're marketing now to their customers that they actually can do. But it initially, you're right, it was a big issue for them. Why aren't we doing more to promote rail? That's a good question. I think the study that ODOT's going to undertake is one of the first that we're doing. Generally, people tend to like rail, so there's, I think, just sort of latent support for understanding the rail industry and the rail network. But part of it is that, unlike, for example, the highways, there hasn't been a tradition in Oregon or elsewhere in the United States to invest public money in rail infrastructure. And then if you look at the profitability of the rail lines and where they want to invest that profit, it hasn't been in the short line or the short distance markets. However, again, as congestion increases and it gets back to this issue of reliability, I think we may see more of an interest in maybe some joint public-private partnerships and understanding some of the shorter rail movements and how we can invest in short line rail to accommodate what you're suggesting.
Speaker, I want to announce next week's presentations. We'll have two of our very own MERP candidates, Steve Hansen and Tom Mose, presenting. Steve will be talking on the portal, the Regional Data Archive, which in the very near future we'll be able to be counting truck information on the freeway systems, and we'll be archiving that. And Tom will be talking about public elementary, middle school siting issues. So with that, I'd like to thank Scott for a very informative and interesting discussion today.
Thank you.